Hi everyone, welcome to today's video. My name is Sam and I'm an outdoor educator at Venture Outdoors. At Venture Outdoors, we focus on removing barriers so people of all ages and abilities can enjoy everything being outside has to offer. While we aren't able to enjoy the outdoors together right now, we can still find ways to learn and experience cool things about the outdoors, like through this video. Today's video and the others like it will cover an outdoor related topic while tying in a STEM component. After the lesson, we'll do a fun experiment that you can complete right at home. Today's lesson is about parachutes. We'll talk all about what parachutes are and how they work and how the science behind them is used elsewhere in nature. After that, we'll make our own. So let's get started. Have you ever seen or used a parachute before? Where might that have been? There are many different kinds of parachutes that can be used in different places. Whether it's using one like this to play with your friends or one like this to skydive, there are two very different uses, but they work in the same way. Parachutes are big pieces of material that help slow the fall of something. They've been around even before airplanes. Some variation of a parachute has been documented as early as the Middle Ages. Modern parachutes began to appear in the mid 1700s and were big circular pieces of cloth. Today, a square shape is common as well, and the materials used are much stronger than normal cloth. So let's talk about the structure of a modern parachute. Parachutes today are made with very strong, stretchy, maneuverable, nylon-like cloth that is extremely tear resistant. They are stitched together using strong thread, and the stitch count per square inch is very high, so it will stay together even if it malfunctions. While not being used, parachutes are tightly packed into a backpack, but they're packed in a certain way that will guarantee the chute will open correctly when the lever is pulled. Once that lever is pulled and the pilot chute helps the main chute open, the large cloth will form a canopy-like shape that will help the user fall slowly to the ground. The user will pull on the control lines to help them steer as they fall. Modern parachutes even have holes in them, but these holes are specifically designed to help the user as they fall back to the ground. Why do parachutes work? Think about it. If I drop a ball in front of me, it falls right to the ground. But if that ball is attached to a parachute, it would take much longer to get to the ground. This is because of a force called resistance. This is the main science behind a parachute being successful. If the parachute creates enough resistance, it will slow the object down. Resistance is created when air has something to push up on as an object is falling through it. With more air resistance, the slower the object will fall. Think about when you dive into a pool compared to when you jump. When you dive, you enter the water much faster than if you do a belly flop or cannonball. This is because when you dive, your body parts the water more. With a belly flop, the water can't get out of the way in time. While a belly flop in the water is more painful, it's resistance in the air like that we want when we're using parachutes. Parachutes are not the only thing that rely on air resistance to work. In nature, birds are doing the exact same thing. Birds use a force called lift to take off from the ground, but once they're in the air, they rely heavily on resistance to stay there. As a bird glides, the bigger the wings, the better the resistance, or drag, is created. But just like when we dive into the pool, if a bird wants to dive for prey or land, they'll make sure their body is creating less resistance to make the dive quicker and more successful as they head towards the ground. So now that we're parachute pros, let's try to make our own. I'll be making two different types of parachutes and comparing how they work. If you don't want to make both parachutes, making one is fine too. Here are the materials we'll be using to create our parachutes today. String, scissors and tape, a coffee filter or plastic bag or napkin, and then a small object to test the parachute. These items should be available in your kit, but if you can't find them, you might be able to locate them around the house. Our goal for today is to assemble a parachute like the ones we've seen in the presentation so far. While we're doing that, think about resistance and how you can make sure your parachute has enough resistance as it falls to the ground. When you're done, you can test it out. Throw it up in the air and see how it falls. Once we're finished up here, you can throw it out a window or outside and see how it works from a larger distance. If you're struggling to get started, that's perfectly fine. I'm going to be working through my coffee filter parachute, so you could follow along with that. But if you have your own idea too, that's perfectly fine. You can go ahead and work on that. So if I take my coffee filter and think of it as a clock, I want to cut holes at the 12, 6, and 9 and 3 sides. This is where we'll put our string for the rope of the parachute. Make sure you cut the holes in far enough, but also make sure they aren't too big that they're messing with the structure of the coffee filter itself. Once you're done with this, you can take your string and start to feed it through. Now there are two different ways you can feed through. I will take my string, and what I like to do is, if you have similar string, you cut two big pieces and feed it through one and feed it through another. So we'll take it and we'll feed it through one there, and then the one next to it, we will put it through there. So after that, we'll have something that looks like this. There's the coffee filter, and that's what the string should look like. Once we're done with that, we'll do it on the other side the exact same way. The other way to do it is to cut the string into 4 instead of 2 and tie each one to each little hole, but that's a little too much work for me. So I'll be doing the 2 strings. Once we have our 2 strings in, do that second string the same way as the first one. We should have something that looks kind of like a jellyfish. So we have, that's the top, and then these are the way the strings will fall. So the next part is kind of the tricky part. We have to take our object, which if you have a kit, you should have a small, tiny animal or something like that, and we have to tie the strings to the animal to make sure the animal sticks to the parachute as it's using it. So I will take a corresponding piece of string and tie it to the leg of the animal. So I will take one leg and tie one piece of string to it. So that's what I have so far. And then I don't want to get it all tangled up, so I will make sure I will match. So this one went on the back leg. So the next string on the same side will go on the side right leg, the front right leg. Tie the same kind of knot. Having some trouble with the knot. That's perfectly fine. If at any point you're having the same kind of trouble, you can ask an adult and they'd be happy to help you. Here we go. All right, so those 2 are complete. And then I will go and do the other side. There we go. Make sure you're tying the knots as close to evenly as possible. It might just be easier. The animal will fall down smoother if the string lengths are about the same. All right, last knot, here we go. And I'm not very good with knots. Maybe this will be it. Yep, there we go. All right, so in the end here, after I untangle my strings and animal, I have, and really that's what the tape is for too. If you get impatient with this like I almost did, you can just tape the animal to the strings and that's perfectly fine as well. But my finished product is a jellyfish looking parachute up top tied to the cheetah here at the bottom. So to test it out, think about what we've talked about with air resistance. The air should push up onto the parachute and help the cheetah have a much slower fall to the ground. Now I'm going to throw this up and try and get it in the camera. We'll see how it goes. All right, not bad. You can see it did fall slower than it would have if I just dropped it, but it wasn't the best kind of resistance that we were looking for. So next, I'll try the plastic bag parachute and see how that works. All right, so now we're going to try our second parachute of the day, and this will be the plastic bag parachute. So what I like to do is get my plastic bag here, and where the handles are, I like to cut the handles. So again, like we had 4 strings with the coffee filter parachute, we'll have 4 places to tie string, again, on the plastic bag. So we'll take our string and do the same thing. We'll take our long piece of string that came in our kit and we will cut that in half. And then this time we'll take those 2 pieces of string and cut those in half. So in the end, we will have 4 roughly even length pieces of string. Perfect. Now, with each string, you know what? These are pretty long as they are. So, did we cut those in half again? Let's cut those in half again. So now you'll have about 8 pieces of string, but that's okay. We'll only need 4. So take half of those and just set them aside. You can use them to build a different parachute later or use them for something else. So now with the plastic bag, you might have to tie 2 knots this time per string. So we'll take 1 string, 1 end of the bag, and tie a knot. Again, try to make them roughly the same length on every side. So this is what I'll have. I have a knot and then string. And I'll do that 3 more times, and then we'll tie our animal on. So here's string number 2. All right, string number 2 tied. So this is what I have so far. I have 2 pigtail looking ends of the bag with strings tied to them, and I have 2 more to go. String number 3. Tied. Last one, string number 4. All right, string number 4 tied. So we have 4 strings tied to the bag and 4 loose ends. Now what we're going to do is we're going to take those 4 loose ends, and just like with our coffee filter, we're going to tie 1 end to each leg. But because we're low on time, kind of, I will take the tape method and just tape my cheetah to the strings. When you're doing this, again, make sure you don't tangle the strings. Like in real life, that would be problematic. So take the ends of my 4 strings here, and I'm going to wrap them a little bit around the cheetah. And then I'm just going to throw a big piece of tape on the cheetah. And make sure all the strings are on there. Oh wow, that was only 2 of the strings. So I will get another piece of tape and tape the other 2 pieces of string onto the cheetah. Perfect. There we go. Okay, so our lack of time cheetah now looks like this, all the strings taped together and a bag on it. So there it is, right side up, cheetah, bag, and now what we're going to do is we're going to toss the bag up and see how that works. So that fell a little bit slower than the coffee filter. That's because there was much more space for air to fly up into and cause more resistance as it falls to the ground. So how did our parachutes come out? Did they work? Did they not work? Either answer is okay. If you want to give it another shot, if yours didn't work, that's perfectly fine. Just think about how you can add more air resistance to make that parachute work and help the animal fall slower to the ground. So that's all the time we have for today. But before we go, let's do a quick review of what we've learned. Parachutes have many uses and have evolved over time to become pieces of strong fabric that greatly slow the falling speed of the user. This is because of a force called resistance. When air has more space to push up on something, resistance is created and the object is slowed down. This force is not only present in the science of parachutes, but it's also used by birds when they glide through the sky. Our coffee filter and plastic bag parachutes both demonstrated resistance as they helped our object fall slower to the ground. Thanks for watching, everyone. We'll see you next time.